Okay, think about this for a second. Flowing through your veins right now is this incredibly complex liquid code. And this code, well, it determines so much about who you are, and in some situations, it can literally be the difference between life and death. Today, we're going to crack that code.
So here's the big question, right? We've all heard about blood types, A, B, O. But have you ever really stopped to think about why getting the wrong one is so incredibly dangerous? Why can a simple transfusion go so terribly wrong? That's the mystery we're solving today, piece by piece.
And it all starts right here, with blood groups. Honestly, the easiest way to think about them is like a unique ID card for every single one of your red blood cells. These little IDs are actually molecules on the cell's surface, and they're called antigens. And your body, well, it's like the world's strictest bouncer. It knows exactly which IDs are on the guest list and which ones aren't. So if the antigens are the ID badges, then floating around in your blood plasma, you've got these security guards. We call these antibodies. And their one and only job is to hunt down and attack any cell that shows up with an ID badge they don't recognize. And that, right there, that is the fundamental conflict that makes this whole blood transfusion thing so high stakes.
Okay, so this brings us to the first major piece of our puzzle, the famous ABO system. This is pretty much the main rulebook for safe blood transfusions, and if we can understand this, we're well on our way to cracking the code.
Let's just walk through this chart together. See the row for type A? It's got A antigens. Its ID badge says A, and its security guards, the antibodies, are trained to attack B. Now look at type B. It's the complete opposite. But this is where it gets really interesting. Look at type AB. It has both A and B antigens on its cells, which means it doesn't need any security guards for them. And then you have type O. It has no A or B antigens at all, so its security team is on high alert for both. This simple logic is the absolute key to transfusion safety.
And that logic leads to two really special cases. Because type O blood has no A or B ID badges to set off any alarms, it can be given to pretty much anyone. That's why we call them the universal donor. And on the flip side, since type AB people don't have security guards for A or B, they can safely receive blood from any of those groups. They're the universal recipients. Pretty cool, right?
But you know, the ABO system isn't the whole story, not even close. There's another layer to this mystery, one that becomes absolutely critical during pregnancy. It's called the RH factor. It's a whole different kind of ID badge, and whether you have it or not can create a really dangerous situation.
So this extra ID badge, this RH antigen, is found in about 80% of the population. We call those people RH positive. The other 20%, they're RH negative. And it's a very specific mismatch involving this smaller group that can create a hidden danger, not for the mother, but for her unborn child.
So here is the specific puzzle we need to solve. Why is it that it's not the first pregnancy that's the problem, but the second one? And only when you have this very specific combo, an RH negative mom carrying an RH positive baby. What is going on here that makes this so incredibly risky?
Okay, let's break it down. Act 1, the first pregnancy. We've got an RH negative mother and an RH positive baby. For the whole 9 months, everything's totally fine. But during delivery, it's possible for a little bit of the baby's blood to mix with the mother's. Her immune system sees the baby's RH-positive cells, spots that foreign ID badge, and thinks, intruder. It starts to slowly build an army of anti-RH security guards. But the key here is that this process is slow, and the first baby is usually born long before that army is big enough to cause any trouble.
Now, let's get to Act 2, a second pregnancy, with another RH-positive baby. This time, the mother's immune system is not starting from scratch. Oh no. That army of anti-RH security guards is already trained, armed, and on patrol. And here is the critical, dangerous detail. These specific antibodies are small enough to cross the placenta. They slip right into the baby's bloodstream and launch an all-out attack on its red blood cells.
The fallout from this internal war is just devastating. The condition is called hemolytic disease of the newborn. With its red blood cells being destroyed, the baby becomes severely anemic. This triggers all sorts of other terrible problems, jaundice, organ damage, and in the worst cases, it can actually be fatal. But thankfully, this is one of those stories with a hero, modern medicine. The solution is just brilliant. It's so elegant. Right after her first delivery, the RH-negative mom gets an injection. This shot basically acts like a cleanup crew, mopping up any of the baby's RH-positive cells in her system before her own immune system even gets a chance to notice they're there.
Her body never gets sensitized, and that whole dangerous cascade is prevented from ever starting. Just amazing. All right, for our final puzzle, we're going to look at a universal miracle that our blood performs all the time, stopping a bleed. You get a cut, and almost like magic, the bleeding stops. How does your body mobilize this incredible emergency crew to patch the leak? The science behind it is just absolutely fascinating.
The official name for this process is coagulation. And really, it's just the process of your body forming a solid plug, a clot, right where it's needed most. It's this incredibly complex, rapid response system designed for one thing: to keep your precious blood where it belongs, inside your body. So how does this whole emergency response get started? You can think of it like pulling a fire alarm. The very instant a blood vessel is damaged, the tissues around it release a flood of chemical signals. These signals are basically an instruction to create a very special enzyme. Let's call it the activator. This is the first responder on the scene, and its job is to kickstart the entire process.
And now, a lightning-fast chain reaction begins. That first activator enzyme finds a protein that's just been waiting around and wakes it up, turning it into a second enzyme, the formin. Now, this formin is the real construction boss. Its job is to find another protein that's just been floating around dissolved in the blood, and it gives it one single command: solidify! And instantly, that protein transforms from a liquid into these long, sticky, solid threads. These threads form a net, a mesh that traps blood cells, and boom, you have a physical plug that seals the wound.
So there you have it. Pretty incredible, right? We've managed to decode some of the most critical secrets hidden away in our own blood, from what makes transfusions work, to the hidden dangers in pregnancy, and the absolute miracle of clotting. Let's just quickly review the codes we cracked.
So let's boil it all down. First, your blood type is basically an ID system, and your body's security guards will attack any ID they don't recognize. Simple as that. Second, that same security system can sometimes mistake an unborn baby for an intruder, but thankfully we have a brilliant medical fix for it. And finally, your body has this amazing, fully automated emergency crew that can build a patch at a moment's notice to stop you from bleeding. It's just an incredible system.
It's truly amazing when you stop and think about it. All of this is happening inside you, right now, every single second, without you ever having to think about it. Which, it just leaves me with one final question for you to chew on. What other hidden biological miracles are protecting you right this very